So we're on lesson 7. So again, we're going to have a quiz tomorrow on everything that we've learned so far in trig. Right? And also tomorrow, in case you guys don't already know, you get a Christmas dinner tomorrow. So it'll be happening during our block. So after the quiz, then we'll go down as a class and everyone gets Christmas dinner. So remember, our trig ratios are the sine, cosine, and tangent. They can only be used if you have a right triangle. And you will be given these for your quiz and your test coming up. But we also have SOHCAHTOA, which tells us what those three ratios are. Right? The SO part means that sine is opposite over hypotenuse. The CA part means that cosine is adjacent over hypotenuse. The TOA part means that tangent is opposite over adjacent. So some new terminology today is angle of elevation and angle of depression. The line of sight is the invisible line from one person or object to another person or object. It's basically what your eyes are seeing, the direction they're going. Some applications of trig involve an angle of elevation and an angle of depression. The angle of elevation is formed by the horizontal and a line of sight that is above the horizontal. So as the diagram shows here, you've got a house and you've got a large tower. The angle of elevation is measured upwards from the horizontal. It's measured from the house up to the top of the tower. Basically, it's the angle that your eyes will shift from looking straight out to looking up at the top of that object. The angle that your eyes shift to look up at that object is the angle of elevation. Whereas the angle of depression is measured downwards from the horizontal. If you're up high and you're going to look down at an object that's lower, it's the angle that your eyes shift from looking straight out to down at that object. The angle of depression is measured downwards from the horizontal. And one other thing that's not told here or stated is that the angle of elevation from an object up to another object will be equal to the angle of depression downwards from that object to the object that's lower. Those two angles are always equal. And that's important because to use trigonometry, you have to have an angle inside a triangle. If you have angle of depression, it's not inside the triangle, it's outside the triangle. But remember, the angle of elevation and depression are always equal to each other. So we'll use that. So this first example says that Natalie runs a scenic chairlift ride that overlooks part of Marble Mountain in Newfoundland. Tourists get on the chairlift at the bottom and take an 1,800-meter long ride up the mountain. The cable that the chairs ride have a 36-degree angle of elevation. So that's this angle right there. It's the angle measured upwards from the horizontal. A tourist wants to know the horizontal distance that the ride travels, which is what x is. Horizontal is straight out. What is the horizontal distance to the nearest meter? And also, if it takes 6 minutes to ride from the bottom to the top, how fast is the chair rising in meters per minute? So there's two things that we're going to have to find here. The first part is to find x, the horizontal distance. So let's say we'll label that part A. And remember, when we're using trigonometry, we always label the sides of the triangle. The side across from the right angle is the hypotenuse. We're given that 36-degree angle. We're going to use it. The side across from that is the opposite. The third side is the adjacent. So for this first part, we wanted to find out what x, the horizontal distance, is. That means we're using the adjacent and the hypotenuse, which is the cosine ratio. The cosine of 36 degrees, that's our angle. And again, the order matters. The CA part tells us that it's adjacent first, hypotenuse second. Adjacent on top, hypotenuse on the bottom. Make both sides a fraction, cross multiply. 1 times x will equal 1800 times the cosine of 36 degrees when you cross multiply. So again, make sure that the calculator is in degree mode, and mine isn't. I used it for something else, so I had to change the mode for that. And now we can go 1800 times the cosine of 36. So that is the horizontal distance that the chairlift travels. How far forward it goes, 1456.2 meters. That's part A, the first thing we're asked to find. The horizontal distance to the nearest meter, I guess. So then we would round that to the nearest meter. It would be 1456 to the nearest meter. Now, we also want to find how fast the chair is rising in meters per minute. So here's how we do that. We need to know what the length of the opposite side is to do that. So let's call that h for height. That's going to be the first step. And I have two options. I can use Pythagorean theorem if I want, or I can use another trig ratio. I'm going to use another trig ratio. Both would work, but I've just decided I'm going to use another trig ratio because I've already got my triangle set up for it. All I have to do is circle h with the hypotenuse. So now I'm using the opposite end of the hypotenuse, which makes us use the sine ratio. So the sine of the angle of 36 degrees equals h over 1800 because sine is opposite over hypotenuse. Make both sides a fraction, cross multiply, and h will equal 1800 now times the sine of 36. In the last part we did 1800 times the cosine of 36. This time we're using sine. So it's going to give us a different answer because we're using a different trig ratio. 1800 times the sine of 36 degrees is 1058 meters. So that is how high the lift is going. That's the change in elevation. And we want to know how fast the chair is rising in meters per minute. So if we want to know what the rate of change is in meters per minute, that means meters over minutes. In this case here, we're told it takes 6 minutes to ride from the bottom to the top. So the rate in meters per minute will be 1058 meters over 6 minutes. Meters per minute means meters over minutes. Meters divided by minutes. So I can take that number in my calculator, divide it by 6. So it's approximately 176.3 meters per minute. 176.3 meters per minute. That's the rate of change. That's the rate that the chair is rising. And so we had to know the height of that triangle, how far the chair actually rose to get that rate. Okay, on to the next page. Callum is a cargo agent at an airport. He loads and balances equipment and cargo inside airplanes. So you can see the diagram there. It says that he uses a ramp that is 5.1 meters long. to load cargo into the planes. The angle of elevation of the ramp is 7 degrees. How high is the ramp from the ground to the plane? Correct the 2 decimal places. So that's a very small triangle. It may be helpful to draw a larger one. Okay, the angle of elevation is 7 degrees. Again, that's measured from the horizontal looking upwards. And the ramp itself is 5.1 meters long. We want to know how high it is. What is the height? So we start by labeling the sides of the triangle. There's our right angle, so the side across from that is the hypotenuse. The side across from the angle we're going to be working with is the opposite. The third side is the adjacent side. Ireland, which 2 sides will we use here? Say again? Which uses what ratio? Sine. Okay, because we want to find h, which is the opposite. We're given the 5.1, which is the hypotenuse. We're not given the adjacent side, not asked to find it. And again, SOHCAHTOA tells us that the sine involves opposite and hypotenuse. The sine of the angle. And the SO part tells us it's opposite on top, hypotenuse on the bottom. Got to be in that order. Make both sides a fraction, cross multiply. 1 times h will be 5.1 times the sine of 7 degrees. And we're asked to round that to 2 decimal places. 5.1 times the sine of 7. So it's 0.62 meters high. That's how high the ramp is. Example 3 says Emily is touring historical lighthouses in Nova Scotia. While she sits at the top of the Peter Island Lighthouse, she notices that she can see Sweet Cake Cove across the water to the southwest. The lighthouse is 13 meters high, and its base is 19 meters above the water. So you can see that on the diagram. The lighthouse itself sits on top of a cliff. The cliff is 19 meters high. The lighthouse itself is 13 meters. Emily estimates that she looks down at the cove with an angle of depression of 5 degrees. So you can see that's labeled up at the top there. Angle of depression is measured downwards from the horizontal. What is the approximate horizontal distance from the lighthouse to Sweet Cake Cove? So you can see it's labeled on the top, which would be the same thing as the base of that right triangle. Also, we have to realize that the 5-degree angle right now is outside that triangle. We need an angle inside the triangle. But remember, the angle of depression from the top of the lighthouse down to Sweet Cake Cove will be equal to the angle of elevation from Sweet Cake Cove up to the lighthouse. And now we have an angle inside that triangle. Note that over on the left here we have 32 meters for the height of that triangle. That's the sum of 19 and 13. So we'll label the sides of the triangle. Side across from the right angle is our hypotenuse. We're going to use this 5-degree angle down here. The side across from that is the opposite. Third side is the adjacent side. We want to find the adjacent side. We're given the opposite. So we're going to use the opposite and the adjacent, which is the tangent ratio. So the tangent of the angle, which is 5 degrees, and the TOA part tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. Make both sides a fraction, and when we cross multiply here, we do not have x by itself. The x is multiplied by the tangent of 5 degrees, and on the other side, it's 1 times 32. When we cross multiply, we don't have x by itself, so in this case, we've got that one extra step to do. We're going to divide both sides by the tangent of 5 degrees to get x by itself. So to the nearest meter, it says, we'll go 32 divided by the tangent of 5 degrees. To the nearest meter, that would be 366 meters. Right? The digit in the ones place is the 5, but to the right of that is a 7, which means the 5 has to go up to a 6. So approximately 366 meters. On the next page, Lori is a crew member on a tall ship that sails Bay of Islands, Newfoundland. She often sits in the crow's nest on top of the main mast. So you can see it, it's right at the very top here. The main mast of the ship is supported by shrouds, which run from the top of the mast to the hull of the boat. To make sure the mast is properly supported, the shroud must be attached to the top of the mast at an angle of depression of 78 degrees. You can see that up here at the top. Remember, angle of depression is measured downwards from the horizontal. It's outside the triangle. The mast of the tall ship is 150 feet tall, so we see that labeled there. She notices that the shroud is secured 22 feet, that's the length at the bottom here, from the base of the mast. Does the shroud form the correct angle of depression to support the mast? Remember, it's supposed to be 78 degrees. If not, determine how far the base of the mast, the shroud must be secured to make the correct angle of depression to the nearest foot. So once again, let's draw a triangle here that we can label without being part of that picture, just so we can clearly see what's going on. So the mast is 150 feet tall, and the shroud is connected 22 feet from the base of the mast. She thinks that the angle of depression, which is measured downwards from the horizontal, is 78 degrees. Which means that the angle of elevation upwards should also be 78 degrees. But we're going to check to make sure that it is by finding the measure of this angle here and seeing if it is 78 degrees, because that's what it's supposed to be. So that's what we're going to find. The side across from right angle is the hypotenuse, which we're not going to work with here. We want to find angle theta. The side across from that is the opposite. The third side is the adjacent side. So we're going to use the opposite and the adjacent, which is the tangent ratio. The tan of theta, and again, TOA tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. And because we want to find the angle, we're going to have to go tan to the negative 1 of 150 over 22. That's how we'll find theta, by going tan to the negative 1 of 150 over 22. So second function tan of 150 over 22. So it's actually 82 degrees if we round to the nearest degree. So it's not at the right angle. It's supposed to be 78, but it's too big. So that's the second part of this. If not, determine how far from the base of the mast the shroud must be secured. So I'm going to draw a second triangle here. we want to know what d, the distance between the base of the shroud and the mast, needed to be. If the angle is 78 degrees, the height of the mast cannot be changed. What we can change is how far away from the base of the mast the shroud is connected. And it should be connected at a point so that the angle of elevation is 78 degrees. That would mean that the angle of depression from the top down would also be 78 degrees, because those two are always equal. So what is the distance that the shroud should be connected away from the base of the mast so that the angle is 78 degrees? Side across from right angle is the hypotenuse. Again, we're not going to use that. The side across from the 78 degree angle is the opposite. Third side is the adjacent. Once again, we're going to use the opposite and the adjacent. Which once again is the tangent ratio. So the tangent of the angle, which is now 78 degrees, will equal, and again the TOA tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. Make both sides a fraction. When we cross multiply, it'll be d times tan of 78 on one side, equaling 1 times 150 on the other side. And like we've seen before, when you don't have the variable by itself, we have to do one other extra step. In this case, that would be dividing both sides by tan of 78 in order to get the d by itself. So we're going to find d, and we're going to round it to the nearest foot. So 150 divided by tan of 78. So approximately 32 feet is how far away from the base of the mast the shroud should be connected, right? It was 22 feet, but that gave us the wrong angle. So it should have been 32 feet so that it was the right angle, 78 degrees. Okay, so you got to remember, angle of elevation is measured upwards from the horizontal, whereas angle of depression is measured downwards from the horizontal. So again, we're going to have a quiz tomorrow on what we've taken so far. So we've got, I think, 2 more lessons to do, one on Friday, one on Monday. On Wednesday will be our trig test, okay? And then, like I said before, we're going to be done this chapter. We're going to be done the course. The only thing we'll have left to do is something called puzzles and games. So we'll be doing that maybe next week on Thursday if you're here. And all it is just, I've got some sheets photocopied with some websites to go and play some logic games online. But after Christmas, for the most part, it'll be getting ready for the final exam, reviewing for the final exam. Remember, if you can get your mark to 75, you don't have to write the final exam, you're exempt. Also remember that if you have any missing assignments in Power School, they got to get done and handed in, otherwise they're going to go into zeros. Right now they're not affecting your mark, but they will. If you don't hand them in, they will affect your mark. They'll go in as zeros and your mark will go down. So if you're sitting at 75 now, but you've got a bunch of missed assignments, it won't stay 75. Okay? Yes, Kira. You bet.